So we have with us Aayush Raina, and so he's from Cochin University, and I was just telling about you, Ayush. So he's from Cochin University, and he's right now in semiconductor industry, and he will take you through how it is for him. Over to you, Ayush. Thank you so much.
Thank you. Okay, so is my screen visible? I hope it is.
Yes,
Uh,
yes, it is.
okay, so today I have very less slides to cover, six or seven of them. So what we'll do is we'll quickly go over these slides and we can have questions. Or if you would like to discuss on one particular topic in between, you can stop me and we can discuss. Feel free, it's very open session. I would not like to talk more about what I have done. I'll try to have a session in the direction where I can tell what are the opportunities present in this domain which I have seen. And when you are studying in college, I frankly speaking, I couldn't find these applications whether they are present or not. Once I landed up in the industry, I started seeing them, and I realized that these are very good domains to work. And I am a big fan of semiconductors industry. That's the reason why I'm there in almost like close to 10 years now in semiconductors. But feel free to discuss. Okay, so quick agenda. I'll tell something about myself, and then we discuss about telecom, and then we'll talk about semiconductor industry, and then whatever time is permits, we'll have open questions. If you have some questions about the other domains also, or mix and match of these two domains, or around these domains cross-linking with other domains, we can discuss them also if required. Okay. Okay, so from my side, very quick introduction. I'm close to 11 years now in industry, close to 2.5 years in telecom, 9 years in close to 9 years now in semiconductors. Now, currently, I'm working as an architect in Applied Materials India. Basically, it's a US-based company. It's a market leader in making semiconductor manufacturing equipment. When I was there in telecom, I was working for a private player called Chinese player called Huawei. It was a big hit, hot shot at that time, 2010. But we'll discuss about the downfall also, if time permits, of Huawei, because uh, because of Cisco, US markets, how they strategically took Huawei out from their countries and took the control back. Google threw Huawei mobile segment out. So we can discuss us if time permits on this area as well. It's more of a company politics, but it's very interesting if you would like to hear about it. Then I have a kid. He's close to 4 years now, and I started my master's in ML journey, machine learning, in last year because of pandemic. So I thought of engaging myself in something, and I felt like you guys also should start this journey very soon. I took nearly 10 years to realize it, but it is something which we should have as an like when you say you're a software engineer, you should have a skill set of data structures and algorithms as an implicit with you, because that skill is something which will always help you to think in a you can say more analytical way or cognitive way. Similarly, I feel in the coming years, ML will be a strong arm in every company we do. And the way I see industry ramping up, there will be auto generators for code, many frameworks coming, but the human decision, or you can say the skill of software engineer, will lie in analyzing the data which we have in place and the amount of data we manage. This is something which will definitely make a difference in the coming years. So this is uh, my you can say suggestion. Even if you don't go for a proper course, just once you finish your engineering and you hop into jobs, just find some space in between and do keep a tap on this segment also in your regular day-to-day work. Um, Again, so I strongly believe in listening to good speakers, and 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 the sharing part is also very important. In my college days, we some people, you can say, would used to like to write blogs, and I see them very successful now, compared to me, which I where I started very late in my organization writing blogs. But the sooner you start, the better, you can say, you will be in coming years. If you start with any basic YouTube channels, don't worry about like who's viewing it or not. It depends upon how good you talk on these platforms, how you good you represent or write on these platforms. In our times, things were not that great. We used to have only WordPress, but today you have Medium, you have a lot of good channels. YouTube has a very good support for preparing videos, and all apps are there, iPads and tablets. They support a very easy way of processing these videos and content. So do spend some time on this, on these areas as well. And it is very enriching when you have it in your profile in coming 10 years down the line, that you have a very successful channel, you have a very successful leadership. The more you share, you write some code, try to post it on GitHub. It actually helps in your profile when you try for top big A category companies. It will definitely help you a lot. Okay, let's move ahead. We will talk about something on the telecom domain. So feel free, if you feel like there's something I have to add, or you have a discussion, you can stop me in any of the domains. Okay. Mm, Now we'll start the proper presentation. Okay, first I would like to talk about telecom domain. So in telecom, when we study networking, we study with routers, switches. There is a hot segment. If you are second year, third year, you have must have seen there is a certification group goes on of CCNA and all. I also did my CCNA long back, when just out of college. But it is more about understanding the routing and protocols. Now, if you see, the industry has moved to very, very, you can say, in a different layer. It is more on, you can say, earlier times when we used the devices were not smart. So when I say devices not smart, was like router switches. They were supposed to just collect the data or pass the data around them. But now in this era, the devices have become smart. When you are these devices, when you say your internet router today is a fiber optics router, compared to us when it was a DSL modem. So if you see, today's router is generating huge amount of data compared to what it was generating ours time. For us, 512 kbps was a very rich speed to play online games, but today it is nothing. So so if you see, the centralized servers, or you can say the centralized switches or routers of the area, think about how much devices they are managing. So they have to be very smart. So you can say, over here, if you see, I was working for a software called as U2000. It was a network management software. So when we say network management, it used to manage for the entire city or entire province, all the devices, all cities routers, and then last mile devices also till fiber optics. Basically, in UK we had a British Telecom was a big customer. In China we had a big customer. So in such areas, you have a huge amount of influx of data coming in, and in that time, you can say, we were having 500k 100k devices, this software used to manage. Now think about the time now. Uh, Even if we have same number of homes, or definitely the number of homes will also increase, but the volume of data has been increased. So this software would have seen a huge transformation in terms of a desktop software, you can say, where we used to have, let's say, 100 GB of RAM and few terabytes of hard disk, to a full cloud-based solution where you need, you can say, several thousands of processors, several thousands of services to manage each set of data. So when I say, let's say, in a city, inside one area, one service is managing the same data. So you have a different replication mechanism of same service, but allotting different areas of the city, or to these routers or something like that. So the way the solutions change in these areas is also very interesting. So To currently, if you see, uh, video is something which is a key player. 10 years back it was text, then audio came in case, now it is video. So we really know, now inside video also you can say the next is 4K. So the amount of data which we are seeing flowing through the internet today is something it's which is very challenging to manage. And then you have to bring smartness on this. Every device should be smart, AI enabled. Uh, and this is something where your contribution comes in. You see when you join industry, think about these areas. Like you're working for a software, like in this particular team, when I worked for 2.5 years, we wrote some papers also around how to manage when the device got increased, or the solution got changed because of that. So think about these areas also. Try to write some good papers around it, blogs, internal blogs to the company, then try to convert it to patents. um and your company will support you. In traditional days, you can say 20 years back, companies were more on what bosses used to tell. When I joined, it was more about giving a friendly environment. Now it is more about employee centric, what employee wants to do. Work is something which way we can manage. So if you are a smart developer, you may finish your work in 2 days a week also. Nobody's coming and saying that, oh, you're sitting idle, do this also. What you do in remaining 3 days is your credibility, and how what change you can bring to your, not only to company, but or your own profile as well. So if this is something which is a drastic change, and it's a very welcoming change for developers, I'll say. I myself try to if in industry we work in agile, so we have something called as sprints. So we take 3 weeks of work, 2 weeks of work, some it depends upon company to company and team to team, and 3 weeks of work we take in a chunk and then start working. So I personally finish my work in 1 week itself, and then remaining 2 weeks, I 1 week I allocate for something else, something 1 week for something else. So nobody is coming to us and saying that, "Oh, you were sitting idle, take something more." So this was not there 10 years back or 20 years back, but now you have this flexibility in every company. So do enjoy it. And this is something I would like to talk about in telecom. Is there any specific question related to telecom? I would like to try attempt it. Do you want? You can unmute and ask if required. Feel free. Am I speaking too fast, or it's not clear, or something like that? Please, be open.
You
Okay.
can put your questions in chat too if you don't want to unmute yourself, guys.
Yes. Okay. Another segment I would like to tell, if there's no question yet, I'll segment is I would like to talk about is throughput and memory requirements. This is something which, as a software developer, or as any engineer, you would like to have a challenge. You can say, being a civil engineer, you if you design a highway, your your main aim is to have a maximum influx of vehicles going through. How much you can with the given space, how you design that highway. That's the reason why you use the scale it this way, so that you get 4 lanes of the small space. So this is the art which is there in software as well. You design your system in such a fashion that your throughput and memory are always in control, and you will maximum times you would like to cherish these kind of problems. And these are like very good for showcasing also that your system performance was supporting, let's say in this case, for this example, let's say I was supporting 20 routers, for example. How do I scale up to 200, 2000? So this is something you should brainstorm internally whenever you are coming in the project. You should ask your leads or your architects about this. Like, what is a maximum rate? If they don't have number, you measure it. try to see what is the system upper limit, then what is stopping it, where it is getting choked, so how to improve it. That is something which also brings a problem solving in you. And I feel like that is something which has given me a lot of edge in my work. And because if you solve something like this, you get more and more such opportunities. And you if you ask for something different opportunity also, you will get it. Like my company is supporting my ML and AI courses also, along with my work. Some people get MBAs also as part of their work, from the sponsored by the company. But you start getting these benefits because you've showcased certain things, which generally people offlook. It's not like that. Not all people can't do it. It's basically people. Everybody has his own priorities. But if you like and to work, and if you cherish to solve such problems, do try to attempt these things. There's not no you can say uh, downside to it. If you succeed, it's great. If you are not able to do it, at least you will learn something. Okay. Uh, yes. So shall we move ahead? Let's move ahead to my favorite area, wafer fab industry. So I'll ask the question. Maybe try to answer it on chat, or maybe uh, in your maybe if anyone has an iPhone or a regular Qualcomm OnePlus phone, do you know how many uh, transistors are packed inside that?
You can put it in chat, whatever you think is the answer.
Do you
Give
have
a
any?
wild guess.
Give a wild guess. Yes. Let's see. This is people. This is chat. Nobody's answer. Let's say I'll put a number to start. 100K. Now I've started at least.
Come on,
Just
guys.
just play it like an auction.
How many transistors you think are there in an
There's
iPhone?
nobody judging you. Don't worry. Even I was not aware.
1
1
million.
million.
Thank you,
Good.
Arjun, for
Thank
starting
you,
it.
Arjun. Yes, for starting. 1 million is good, but I'm anticipating more. Let the
Guys,
auction
go
continue.
higher.
By this
Come
time, I would have Googled and placed the answer. 5 million. Okay. Better. Let's go up. 3 million. Okay. You brought it down. I wanted to rise it further.
Wow.
Let's see. Okay. Let's see the latest chip. M1 chip. Isa?
Wow, that's a lot. I just wrote 1 billion just for the heck of it, and then it's 16 billion. Wow, that's a lot.
And the latest one which we are working currently, M1X, it has even more. Uh, okay, so I'll talk about first. I erase my meat. Okay, so I'll talk about first. Yeah, Rahul was close. Good. Okay, so how if you see we in 10th and 12th also we had this NPN transistors or PNP transistors, and so you have a material in between, and you have you can say both the sides, this silicon. So the intention here is sorry, you have your intention here is when you heat or when the current passes it through it, the because of this field it starts conducting. Now when you see when the electrons flow, um, they will definitely have some kind of heat associated with it. So that's the reason why in traditional PCs, you have big fans on the processor, and then you have big copper wire, you can say elements running through, which are uh, coming out towards the fan. So the fan basically cools the copper, and then finally that copper cools the processor in the laptops. And on this, in the case of CPUs, directly the fan is on the CPU itself. So this was up till, you can say, when the transistors were packed with the, you can say, in a different way, when you can say in a linear way, horizontal way. Now what happened is when they started packing them close, and there is a law also called, maybe you must have read it, called Moore's law. So what he used to say, it was like every year, or you can say every few years of cycle, the number of transistors will get doubled in a chip, and you can say the area will become half. So this is something which was Moore's law, and it was coming from right from 70s, when you used to have vacuum tubes to create these transistors. And once the silicon started, industry started working, and this transformation happening, and the Moore's law was holding very good till 2011, 2012. After a while, it started become impossible to follow that. Like to the space crunch was so huge that the transistors were very close to each other, and they were burning out. And the reason being is the heat, or amount of heat it were getting. No matter how good coolant you use, they were burning out. So Intel at that time was market leader. Now Intel has lost the battle to many other players, but Intel was a very, very big player at, you can say, 5 years back. So Intel has a patented technology which already i3, i7 processors of seventh generation onwards are using, which is called as FinFET. So what they started is doing is they started making the transistors in form of a fin of a fish. So if you see my screen, I'll just show you the picture of it. FinFET. Sorry. So if you see this, this is kind of a fin now. So the gate started becoming very big, like a fin, and as a result, the heat started flowing on the top. So they were able, since they gave a space for the heat to go around, and the number of the areas also was good enough, and the gate also became smaller. As a result, the large volume of current could flow, and basically you can transfer more data that is directly proportional to current amount of current which is flowing. And as a result, you have the faster the current is, the faster the processor is, and the amount of heat it generates, it's also getting dissipated. So you started seeing ultrabooks from that era onwards, because th- once the only challenge in the notebook computers was the fans. The once you challenge the heat problem, the fans could be removed, or they could be less, they could be reduced. The size of the fans could be reduced. So now if you see the latest ultrabooks, they are working on a very different technology which you can read about it. And the over there they have achieved somehow, which we call it as fanless. So these new ultrabooks of Apple, you can say, are fanless technology based. So earlier Apple was using aluminum. It's not like aluminum is very fancy, but aluminum was helping them to dissipate the heat from these processors, and they were working with smaller fans, and that's the reason Mac was very, very simple, very sleek. So they had a patent, and not everybody could use aluminum, and everybody had to stick with plastic and big fans, and that's the reason why HP laptops were looking very sluggish compared to other Apple laptops or Apple hardware, because they had a patent for very long years. So this is something, a background about the gates. Okay, now we know that we use them. So who manufactures them? So there are people who design it. Let's say you have, as an if EC folks will create a VLSI circuits, work with companies, like Qualcomm is one of them, Intel is one of them. Uh, they make circuits. Apple also has a big arm. ARM is there. Nvidia is there. You can say AMD is there. Now AMD is also very good. So these are the industries which are designing the processors. And now not everybody is you can say interested in manufacturing them, in creating these processors, because creating them is a very big challenge. How to make sure that you create all processors with same kind of uh, optimized way and efficiency. So when you say the transistors. Let's assume what is we saw the number today as 18 billion. Can you tell me when we are packing them together, what is the you can say gap between two transistors? What will be the gap in this case between two transistors? Approximate. I'll say I'll put a number. I placed 1 micron. Please try. Rahul, Arjun, any number. It's okay. It is definitely higher than 10 to power minus 8. Very good. Very good. Very good. So he said 10
It's
nanometers, if you see.
mm, mm.
This is what 10 nanometers he said. So it's very good attempt. And today, i7, i10, M1 chip is 7 nanometers technology. So just imagine 7 nanometers and 5 nanometers, Arjun, very right. And 5 nanometers is currently in design phase is ready. The production phase is getting stabilized in this, most of the places. Okay, so so if you just imagine, if you say 5 nanometer, 10 to power minus 6 is something which you see with a microscope, with an RBC. 10 to power minus 9 is way too small. It is an size of an, you can say, only with electrons you can see. So the industry has moved to a different uh, altogether a different this industry is very very challenging in terms of in research. You have a lot of chemical engineers, you have a lot of PhDs in physics, optics, and you have in electrical, electronics, how, and then you have a very strong arm in data and in terms of software. Now let's talk about how I'll just show you a quick video how actually these manufacturing plants look like, and then we will talk on some parts of the software. Okay, so let's see a small video. This is one of the fabrication plants which I would like you to see. I visited them twice or thrice for solving some issues in our software, but this is very interesting. I'll do one thing. I'll take to a YouTube video. One second. One second. I'll copy the link so that you can see the. Sorry. I think so. You will. Uh, Sorry, bear with that. Okay. Can you hear the audio? No. Audio? No.
No, no, not yet.
Okay. Wait a second. Let me. There was an option I was reading in Google. Stop presenting. A tab, video animation.
Semiconductor foundry business model
Now,
and leads the
Yes,
foundry
yes.
segment with its trinity of
so this is
strengths,
something which we
technology
call it as
leadership,
a wafer, and in the previous slide, and over here from this basically it's circular disc, and then you cut it, and we call them dies, and every die is a chip, uh, a processor, and that processor goes in your the packing of the processor which you see around i3 m1, everything is there, but inside it's a very small chip, the
Foundry
size of
segment
this.
with its trinity of strengths,
This is a bare
technology
wafer,
leadership,
which is a starting point,
manufacturing excellence, and
and
customer
these are
partnership.
the uh,
TSMC's
different
fabrication
tools which are being
facilities, or
used.
fabs, feature the most advanced manufacturing equipment. Here, TSMC researches and applies a wide variety of
So
process technologies to manufacture high-quality integrated circuits for customers. Now, let's look inside the fabs at TSMC to learn about the IC manufacturing process. The fab is a giant clean room equipped with many types of air filters to keep the manufacturing environment free from contamination. Air from the outside must pass through many types of filters to eliminate all kinds of particles in order to maintain air quality of the clean room. In addition, the temperature, humidity, electrostatic discharge, pressure, magnetic fields and vibrations in the clean room must also be controlled. Pure water, as well as special liquids and gases required for the manufacturing of integrated circuits, are supplied directly to manufacturing equipment through pipelines running throughout the clean room. Before entering the clean room, personnel must wear clean room garments, shoes, gloves, and face masks to ensure cleanliness. After changing clothes, personnel enter the air wash room to completely remove dust and particles from their bodies, preventing suspended particles from entering the fab. An integrated circuit, or IC, is a system of electronic components and circuits miniaturized onto a silicon chip 1 centimeter square or smaller. An integrated circuit can process a large number of electronic signals and perform many complex functions. If we look at a chip under a microscope, we can see that the apparently smooth surface is actually stacked with many components of different heights and shapes. How are these components fabricated? Let's start with the raw materials used to make the IC. Silicon wafers are a type of semiconductor material, and the basic raw material.
So I'll pause it here. So maybe I'll send the video to you. You can have as part of presentation. You can see. So basically, I wanted to give you an overview uh, on actually how actually these systems actually look like, and what goes inside the regular day-to-day fabs. We don't work as software engineers wearing these suits inside, of course. We hardly go once or twice if there is something something is stuck, like these chips or wafers get stuck due to some reason. Then maybe we'll have to enter, or there's something which can be done only on the tool itself. Then we go it, because there's a huge process, exams to be passed to enter these fabs, because there are a lot of checks, acids, protocols to be followed. You saw some robots going taking these containers on the top, so you have to make sure that whatever you're doing with the tool, their pipeline doesn't get affected. So there are many companies involved in this. So there are in this manufacturing process, some are making tools, some are making chemicals, some are making robots, some are making wafers. uh, we and in our company, you can say in applied materials, we provide a long fleet of tools, in long list of tools here, and I work for a specific one which we will talk now about, and how I'll tell how what as a software engineer we do in that. Just let me share my screen back. Mm. Okay, so let's see what we are doing. Okay, so I'm working on a project which is dealing with from you can say on and off. I was with this project from 2013 onwards, if to be very specific. And what this basically what we are working currently is something like this particular fleet of tool is seeing this particular wafer or the disk which you saw in using an optical microscope, or you can say lasers, so 10 to power minus 6. And with 10 to power minus 6, it generates huge amount of alarms which could be possible, defects while depositing copper, or some metal has come at a wrong place, breaking the circuit. The chip may be useless, or maybe chip has a defect which can survive. So I work on the inspection part of these chips, our software basically. So these are $1 million tools which are generating. We are reviewing the wafer with a very high scale lasers, or you can say optical domain from the photons, and it gets a lot of alarms. Just a disclaimer that we are not into science as a software engineer on them. For us, it's just data. There are some points, there are some coordinates, and we just get a data. Then there is on the other right side, we have a different tool, which scans the wafer using electron beam. So this is 10 to power minus 9 tool. But if you see this, the left one is faster. It can generate more data, but it is not accurate. The right side is very accurate. It's a class apart. It can drill down and see, even go one layer below the surface and find a defect there, because these are 3D structures when you make memory or chips. These are 3D now. So in the current, so one, but the problem with this guy is that he's very slow because he's working with electrons. So what we do is, in our team is, we have a next generation technology which we call it as extract AI. It was there published as a proper study also in last year. So it took nearly 8 years to stabilize this particular engine. What it does, it takes data from here, does a machine learning algorithm based on something called as uh, uh, the reinforcement learning. If you have heard something about uh, Google DeepMind challenge, so it is something a similar kind of problem statement we have here. It was a DeepMind was a very big project of to play a game. So this particular problem was, you can see the video also. It's a 1 hour movie, and it's a very nice challenge. DeepMind. So how they created a reinforcement learning, and as a result, uh, there is a game called Go, and they how that basically AI system defeated the world champions several times. And but it's very emotional story. You will see how that guy, who's a very humble person, but he was a world champion from Korea, but he was he never expected that a software could have beat him, but AI could eventually do it. Similar challenge we had it here. We could never expect that this guy can tell us where exactly a true defect is, but with this technology, we were able to reinforcement learning. We were able to do it. So till now, I was managing. You can say solving the problems. We were working in on our team was working mainly on data engineering part, and the Elgo also we had a lot of people there from the machine learning background, from IITs and NITs. But last year onwards, I have started my journey in this area that I really want to explore more on the algo side and contribute because I am comfortable with the domain part. So this is something which I'm currently working on. And as a software in this domain, I have seen that we have good device management. When you say device management, how underlying hardware you use, these systems have a lot of devices, a lot of computers inside them, computation power, cameras, optics, and you have to calibrate those devices few hours. So how you design such complex application flows, and how do you manage? Let's say this guy is generating, if you see, this guy nearly generates 1 billion defects in 1 hour. 1 billion. So that means it will take 1 billion images, and the computers internally are connected with fiber optic cables. So because they are exchanging terabytes of and these computers, these systems are designed in-house by the company, and we have experts in these areas which we're computing. And the processors also, the first level screening which these guys do, which are made from Texas Instruments, and the chip design is also done with some of the team members from here, because the kind of images we have, We need some specialized processors if you have to meet that timeline. So we have good challenges in these areas also of the software. If you like computer architecture, chip designs and all, this is also one of the good segments we can someone can tap in. It is not necessary that e-commerce is a good player. You get into e-commerce. What I have seen in e-commerce industry for architects and software, you cannot write something which can be published as literature easily. This is the biggest challenge in e-commerce. You go, you earn money, it's good, but 20 years flat, you in 10 20 years, you just are picking up new technologies, using them, and you earning money. This is something, one way of working. I am totally accept this, but there are some people, and I'm one of them, who would like to publish something, see something, do some research, do something different off the shelf. And these are the segments which I feel like it requires less effort, less energy in these, but you get have more gain to your profile at the end, and you're working something different. Not everybody gets to work on electron beam columns, right? When you talk about this, I meet some of my relatives who are PhD in pharma sectors. They work in with SEM columns. Some are working with research in DRDOs on pollutions and all segments. They work in SEM. So not everybody, and we have a branch in IIT Mumbai also, chemical engineers. We have a tie-up with them, and we have office location where around 20 people there also. So they actually do some research on the chemical part, and they write a lot of good papers every year. Nearly we publish 2,200 patents every year as a company worldwide, and out of that, India is also from India itself we get around 60 70 papers patents. So it's a very good opportunities in terms of for software as well as for other domains as well. Electronics, it's a blessing to be in this domain. If you have a PhD, you become the owner of the tool. So in Intel, every tool owner is a PhD. He owns it. He knows what each device does, what is the management, and he basically knows it better than us, because he we are just software engineers for him, and he knows in and out of the system, what is the physics behind it, which settings will get him the best images. Okay. The other part which I'm working on is the data engineering and analytics, which I spoke about, is how you scale this volume of data. I was working on data engineering part up till now. Now I'm trying to tap into analytics part of it, decide what data I need, and do some learnings from them, predict something, that out of this, what are the good candidates. This is the segment which I am trying to learn in today. And other part which is very conventional and but very good, which is signal processing and image processing. These tools are generating huge amount of images, so we need proper segmentation to find defects, issues. And if you see, I do some interviews for image segmentation also, and the challenges in this industries are far different to what you have seen today in autonomous cars, which you call as ADAS, automatic driver assistance system, where they detect the object detections is done, pedestrians you're detecting, or you're detecting another car coming from the other side. So all this, and based on that you apply a brake or system gets engineered. So those flows or those segmentations are relatively simpler than what these domains are, because the kind of images over here are black and white, and it's very complex. You don't have a clear resolution or separation of concern. So that is also something, a blessing for you can say, for images, people who have interest in image processing. I would really like that if some people can think on these lines, who are from the electronics background. Final year they have taken an elective for image processing. Personally, my roommate from college, he got third year itself, some university in University of Birmingham. He got some research. you can say as some research proposal got accepted, and he could work there for 3 4 weeks. Then he came back, and now he is PhD, I guess, in image processing itself. But I have seen a lot of PhD. He's also very inclined, and I was discussing once with him that I told him that this is what we do in image processing, and he was very impressed by the work which our teams are doing in image processing. And I would really want you guys to think on this, because benefits wise it is immense, these domains. And you can say research point of view, you get admission once you work with such flows in such industries. You get admitted in any colleges, any for PhDs. You get good opportunities in these industries itself on sites for these locations. So this is also one of the very and plus it is something not very conventional that every person does. I honestly believe that sometimes it just takes a small step towards a difficult domain, and after that the path is very easy, because very simple, because it's a empty road. Nobody is there on that. You can drive as fast as you can, and you can drive slow. There is no rush like e-commerce. Like learn today. 3 years back, my friends were learning AWS. Now they are learning Kubernetes. Now they are learning something else. They front end guys, they started with JSP. Now after that, you can say Angular came, Angular 1 came, Angular 2 came with different architecture. Then React came. After that, now React is also out. There is something else. There are some third-party softwares which are writing Java to JavaScript. People are trying that also with so Vadim. I think so. These kind, and then now Android is also from basically earlier we used to write very simple Android iOS. Now everything has changed. People have come with React Native. Now Google is flaunting some other system. These industries will always change. And if you want to do research, and if you have that tiny bit in your blood that you want to do something research or publish, they will not let you rest. The moment you think of doing some research, the technology itself will shift. So I think so. If you want to go slow and if you want to learn things, target some good companies, target good work also. And I have seen people who were working in device management, easily they went into companies like Apple, because they had seen challenges in bigger computers, and if they are told to solve the problems on Macs, they can easily solve it. Okay, and similarly, people who work on image segmentation, easily they went to Google image photos, image transition systems. Very easy. They had a very good graphs. They published patents in these companies and then made a shift. See, making a shift from Cusat to directly to a company like Facebook or Apple, it won't be easy. But if you tap into the right organizations in the first front, it becomes very easy. Let's say at least at 10 years of experience, I get a lot of opportunities for a tier one companies because of the work which I have done. Similarly, you will also get those opportunities. But if I'm always in e-commerce, not everybody has to go via some, let's say, some 2 3 companies in between, then read 6 months data structure and algorithms, go to Flipkart, then from Flipkart to Amazon, then Microsoft, and then you can jump to Google. This path is good. Most of the people are doing it who want to ramp up. But in nowhere in this path you come to know what actually you want to work. They will put you in different teams, and the only thing is the brand name of the company you're working with. I've seen people who've been working on Flipkart in a different domain. They moved to Walmart in or to, you can say, to Amazon on payment gateways. From there, they jump to Microsoft, to Teams, or you can say devices which are creating conference systems. And from Microsoft, they're taking a jump to Google, which are they working on some technology which is on images. So at the end of six, when you see your profile, it's only companies you have. You don't have a work which is explains your journey. So think about work also, how your work is flowing. Even in you're staying in same company, see your what is your roadmap in that company. So let's say for my example, I've been with this product for from the when it was a baby, and now it is a full marketable product. So at least I know what are the pitfalls of a product when it goes through 8 years of journey where most of the products don't survive.
Okay, 8 years is big time. 2 years, 6 months is a maximum limit where where the upper CTOs or CEOs have give you can say funding for these kind of products. But you have to explain the results on very different things to keep the project alive, and then you start seeing the revenues. Because this product was in the inception phase. It was when we started. It was the gate size was like. I guess 25 nanometers, 45 to it became to 22. So 22 nanometers were not a big thing. Optical was doing this guy was doing a very good job. It used to detect something which was very good. But the moment M1 came, 5 nanometers, 7 nanometers, all tools in industry started failing and data was starting increasing. Then this product got momentum. So we were ready, we were there at first place, so we got the opportunity. Other companies are also there in this race, but they are like 2 years behind us. So I think so. These are the things or learnings I would wanted to share. We still have 5 minutes. If you want to ask something specific, please feel free to ask. I didn't hear any one of you personally.
Thank you, Ayush. That was such a enlightening, session because I think electronics. Even we had another speaker for electronics. He was working in Broadcom, and he also said, electronics is a field which will stay, and it only, the pay, everything keeps getting higher and higher, but people don't realize it.
Hmm.
So I'm glad you put that into limelight, saying that yes, it has a huge scope. So guys, do you have any questions? You can put it in chat. You can unmute yourself. You can ask any question related to electrical electronics or semiconductor industry. Anything. Please feel free to ask. Come on.
Okay, in
And
case you want to connect later also on LinkedIn, you can connect there, ask your questions offline. I'll be happy to assist. Whenever I get time, I definitely try my level best that everybody has a job in hand, as well as everybody has a good work to do, or in case I'll be happy to help in these cases.
there's a question. How long does
Ah,
semiconductor shortage continue?
very good, very good. Actually, if you see this market was very fragile in semiconductors. When I started working in this company, share prices of this industry was $10 in my company. Now it stands somewhere around 160, 10, nearly 16 times. So why I'm just telling you this is like there was a cycle in these industry which was going on. So people used to buy phones, uh, then continue with those phones for 3 4 years. Okay, and then no, once they're continuing with that, the demand used to go down. Then these tools were not getting sold, and these industries who were manufacturing also were not creating something new. So it was a very cycle based industry. 2 3 years it was 1 year, 2 years it will grow, then it will again see a slump, and then again it will grow. So this was a very predictive, a typical time series based pattern was going on. All of a sudden what happened is and because of COVID, everything got got a different direction. The spending pattern of people got changed. So how the spending pattern got changed is people used to go out and travel. So let's say I have a travel budget of let's say 100K in a year. Out of that 1 lakh, uh, entire 1 lakh I cannot spend because I'm not traveling anywhere to with my family. So what I started doing with that is like I started investing in different places. I'm not going out. I'm not buying real estate because there's a dilemma that real estate will also may go down on it. So people found electronics as a very safe option. So everybody started purchasing electronics. This is one side of the story from the consumer experience. Now see it from the industry experience. There were already a lot of hardware, computer systems. Everything was purchased and office setups were ready. Now you can say this created a parallel market, and people started working from home. So you started buying more and more stuff, and same duplicating the stuff. Everybody stopped bought same computer, same monitors at home also. Companies paying the benefits to people and people are buying it. So this is another area where you can say more semiconductor manufacturing was expected. Third case, let's see from the automobile sector. So now uh, everybody was there was a Uber Ola revolution. Everybody was seeing there's a pointless to have a car. No, why should I have a car? In 5 minutes car is ready outside. I don't have to maintain, I don't have to service. I'll pay for my service. There are a lot of coupons, there are everything available, sharing, all those things, options are available. Nobody was buying a car. All of a sudden things got changed. Now everybody is hesitant to use public transport. Everybody is buying a car because they feel much more safer. So now cars started coming in. With cars, people started seeing the market that I also have a savings getting accumulated, and the way I'm working from home, I'm not spending. My spending pattern has changed, and I'm saving a lot of money. I started going for a bigger car, and with the bigger car, I also want to big good features. Okay, so the cars, let's say if you see, I own two cars, and one of the cars is a Suzuki Desire. So in the what I'm saying is the Desire has only one microcontroller. Okay, and there's another car from MG, uh, and it has, let's say, I guess it has microcontrollers in the tires also to measure the tire pressures. So now if you imagine the amount of why I'm telling this to is like the amount of semiconductor getting inside a car also. You have AI enabled, you have digital screen, touch info systems, everything. As you said rightly, this shortage is coming because the vehicle is ready, but the center panel of the infotainment system is not ready. So, so this is the reason why the shortage has come. And if you see how these people cannot create buy so many tools to manufacture it. Let's say they are building one or two fabrication plants extra, but they know once this market will slip, again the demand will go down, then these places or these tools will go useless because it's a billion dollars of investment for them. uh, the industry which I was showing you, it is from Taiwan Semiconductors. So the amount of electricity it uses in one day is actually uh, equivalent to the entire city, like say in Bangalore I live in, for 1 month of usage. If you see, you can read it on Google. It's so much energy these tools take, and they are trying for biofuels, green fuels, and all those things. But they need it's a huge investment for them, and that's the reason they were very hesitant to put, create such fabrication plants based on the demand because they have to see the cycle also when it will come, when it will dip again. So that's the reason why semiconductor shortage will be there at least for next 2 years. And plus, we need a lot of servers. So there are AWS expansion is going on. GCP is there. Google Cloud is there. Everybody is making more and more servers. Reason being just this audio support, which is calls and office calls. Everybody has gone remote, and there's no personalized meetings happening. So even the schools require this. So I think so it will be there for a while in terms of CPUs. That's and car short for semiconductors for cars, least priority because these are like uh, low scale processes, low revenue systems. These generally what happens is like these tools which I'm telling you, this could be first generation tools which are making good processors of Qualcomm, Apple, Samsung, and then it goes once these tools become obsolete 5 years down the line, then they sell it to you can say some private fabs, lower fabs in China and all. They start make using those tools and create you can say chips out of them, and which are used in cars or in the
There
low
is,
end phones.
sorry. There's another question for electronics and communication background students. Suggest some good courses that will help with getting maximum package job security.
Very good question. See, see, there are two parts to it from electronics and communication. So if you are targeting communication, then definitely you will go in telecom. Okay, more. So you decide from telecom point of view if you want to do software in that or you want to do you can say management in terms of routers and all. So you accordingly decide the course. Let's say you want to do software, then definitely your coding skills is definitely required. You ramp up your coding part. You try to solve such problems which are dealing with communication hardwares, communication related problems. And to be very frank, it is more about how the router devices communicate between each other, protocols. You start reading about those protocols. Let's say some devices communicate on SNMP and all those things. Then the other segment in communication you can target is the devices itself, where you have some knowledge of electronics and you want to see how network cards and all this. Broadcom is one of the good example. So you can target those kind of companies. Try to write some good blogs, how network devices work. Read about them, write it. Read one book, write one para. Uh, Very simple. Whatever you learn, just try. I always prefer when you read something. If you think that you know it, or you always I feel like when I want to remember something, or I want to like this is very very good, I would like to remember it. I always feel like let's read it in a fashion that I would like to have teach to someone. In that case, when you learn, that thing will always stay in your mind. So if you ask me automata, I don't remember it, but some things in networks and all those things I remember because I felt like I will be teaching them someday. So or I'll be writing something on that someday. So this is the communication part. In electronics, it's a very wide area. In electronics, definitely think for higher studies. You can work in some company and plan for higher studies. Always keep that market open. Have good results in ACADS for the last 2 years at least, so that your mark sheets are also reflecting what you do. Prepare for GREs and all. Keep giving exams, uh, and if time comes, time is right, go for higher studies in electronics. You will come back or you will not come back, but you definitely wherever you will land after higher studies will be a far far better place. Okay, so this is my suggestion for electronics, but you can always try good companies like Qualcomm, Intel. Uh, Try to find references. Uh, Keep always this thing in mind. Don't try to fight the battle on your own. Always go via reference wherever possible. Let's say I have a friend in Amazon and I want to go to Amazon. I will always go by my friend only, because when you go for an interview in good companies, you will have 6 and 7 rounds. No matter how good you are, no matter how good your day is, one round you will screw up. And that round, if you have a source, that person will fill it up for you. If you ask me, I work in semiconductor, and people who work in Amazon, we have same pass out from same college, same class. And neither he used to study properly and nor I used to study properly. We used to be average students. So there's nothing which has got injected inside him and he started working amazingly good at Amazon. Okay, so what it matters is the right opportunity which has come to him and he cracked it. And the day was good, people and around it was good. And once he's in the team, he's working the same way I'm working in my company. So same goes for my other friends also who are working in TCS Infosys. It's not, no company is bad or good. Ultimately, everybody is looking for their own profits. We are looking for salaries and they are looking for their profits. Bottom line is very flat. Okay, so you try for on and from the electronics and communication point of view, you try on this front. Then Vivek has a question. Can you please tell me the chances in data studies like data science and analysis in your own domain? So one example I gave you about the data science which I am working on. Um, there are there is a platform called Kaggle. I guess you are aware. Try to see 5 years or 10 years back, we used to have platforms like SPOJ, and then ACM was there. I used to go for coding contests there, and then now after when I left the college, slowly CodeChef was ramping up, and now there are Hacker Rank and other things also coming up. But now these platforms, earlier they were like open source, made out of goodwill developers like us. We were working like we used to write code, C rank. Rank was more important. what has happened in these platform, and it has diluted the interest, is they started moving towards hiring opportunities. So they started giving you opportunities, Amazon interview questions, Google interview questions, Microsoft interview. So the interest of the people went away from the learning point of view to cracking companies only, and people were only focusing on the questions which are asking on the company and not on the concepts. So but data science is still not there yet. So data science, you will still have platforms which are just like which was there for coding 10 years back. There are platforms which are very flat. Let's say Analytics Vidya is one of them. Then you have Kaggle. So you get proper hackathons and you participate in them. You first have a learning journey and then you start participate in hackathon. Always try to target the questions which are of on the hackathon based, because you can add it to a profile. Learning from based on what previous companies asked, you just do it. What company is asking is you do it 1 week before the interview schedule. That's it. But regular learning, don't aim for a Microsoft. Let I'm studying for 6 months, just targeting what Microsoft asks the questions. It's pointless, right? And after that, I don't get selected in Microsoft, I'll bang my head. This company I hate for my life. Because 6 months I wasted on that company. If I would have targeted in a different way, I would have targeted that concept. And then 1 week before the interview, I target the questions which they are asking. That's a different case. So I same way for the data science and analysis, you start with Kaggle, and there are private players also now. Don't fall for them. I've taken courses from Upgrad which are very expensive, but my company sponsored it. But there are easier courses which IITs are offering and at a very cheap price. There are Udemy is offering, and I suggest best is YouTube Premium. So I have account for YouTube Premium just for viewing my content. Go for YouTube Premium. It's 129 rupees per month. Most of the contents follow good speakers. I'll send you the links for data science, StatQuest, and all those things. Improve your statistics, and then you jump into this domain. And there is nothing stopping us to, because whatever we learn in first 5 semester in maths, I never recollected. But after when I started with data science, I had to revise everything again. So it's all fresh in your mind. You start with statistics journey early so that you can jump into machine learning domain if required. And I feel like it will be a very strong arm in future. See, when I'm what we have done now is we are going is like every architect is AI enabled or ML enabled. Same way, every manager is ML enabled. He knows to handle the projects which are involving data science. So this will be a secondary skill if you're not a primary skill. So you will need it. Even for faculties, professors, it will be a secondary skill. Do the faculties and have a AI skill also with their domain. And so I remember with Mr. Sudeep, I did one, Dr. Sudeep, I did one paper in first year. We gave programming support in that was on data mining and statistical techniques. Some trend analysis was done for nodal center of Kerala employment opportunities. But that time, whatever sir told, we did it. But now, after when I read that paper again and I see, oh, okay, this is what the concept was. So, but just as this is the data, you have to code it, make some graphs. This is your utility. We did it and gave it to him. Very simple. So, but now we understand things, and we feel like that you should also see that if you are a programmer, it's good, but have a secondary skill. Let's say uh, you will have needs many secondary skills, like say for management, leadership. You will do some courses from IIT, ISB, which your company will sponsor to some extent. But go for those, and if you want to have a primary domain as data science analysis, you decide what you like. You decide to write algorithms, use algorithms, or you want to prepare data for algorithms. So the prepare data is data engineering, then analysis is one part, and then pure data science is evaluating the results. So this is one more aspect.
Any other questions, guys?
Hello, ma'am. Sir, I'm sorry. I thought of typing it, but then I think it will be much better if I just say it out
Yes,
by
it will be. It
unmuting.
is amazing. Please.
So, so like you told us about extract AI, sir, right, sir? The like that happens towards the defect calculation, towards that side, right?
Uh-huh.
Towards the defect determination towards that side. So, is there opportunities in AI and ML? I didn't hear the first part of your talk. I was a bit late. I'm really sorry about that. So,
Uh-huh.
is there any opportunities for AI and ML towards the EDA side, like the roles or the area in which companies like Ansys and Synopsys come into play?
Yes, yes.
So,
Synopsys is also one player. I have our branch topper in this batch was his name is Rishi Kumar. So he was there almost 8 years in Synopsys. So Synopsys comes in the same pipeline. Once this chip basically gets manufactured, uh, they basically do the testing of these final chips. So I showed you the wafer, right? Complete circle disk. So once they cut it and they make small chips, and once these chips then basically go for testing via Synopsys automated solutions. And once the circuits are validated, all gets so generally what happens is like your if you see your processor then it generally has some main circuits and the gates are connected with some main circuits and then you have backup circuits also. So because over the time the main circuits will burn and then the back current will start flowing from the back end. So generally if you see good processors like Qualcomm processors which you use in OnePlus phones, they sustain for a very long time because they're both primary and secondary circuits are alive and they slow down a little bit over the time, but they are still good. Same goes for Intel and Apple processors. They will slow down over the time once the heat because of the heat. But this is something how they work. Now coming back to your question where you were asking in AI part or so you will have a lot of data getting generated from this and then synopsis maybe they have an arm in dealing with the data for the chips amount of chips which is coming but they are definitely not there with the data stream which is generated from these kind of tools. There is one more solution in which I didn't mention in my slide, but you brought it. Is called as CAD, computer aided design. So the electronics team will create the chips using CAD softwares and the VLSI teams. And this CAD is called the core heart, or in some fabs they call it uh, some fab. Let's say if I have if I as a Intel is producing chips, so one fab it will do R&D, and other fabrication plants it will do the production. So these fabs where they do R&D, it's called temple because why it's called temple is they have all design there. CAD is there. So Synopsys provides CAD information also of all these chips. So we take the chips CAD and accordingly that the manufacturing happens just like in automobile sector or you can say any dedicated plants or you cut the metals based on the design or even in now in the same manufacturing industry has come to to you can say furniture as well. These things everything is getting cut according to the design itself in the factories. Same way the CAD is important data and Synopsys deals with that and they call it as a very big link server and and that deals with a huge amount of data because if you see as I explained these are like billions of transistors packed inside the same space. So the design itself is also huge. It's in GBs. The file is in GBs. So sometimes if we have to get it for the entire wafer, it's just like a terabyte of information which we have to bring to imprint something or to verify something. And for the images also we do segmentation with the CAD sometimes to find out like whether there's a defect with the actual image versus the design.
got it, sir. Thank you.
Yeah.
Yeah.
Anybody? Any more questions? Okay.
Okay,
Um,
then
Ayush, can you actually just write down your LinkedIn thing as
yes,
well so
yes,
that
yeah.
in the chat so that, if anybody
Uh,
wants to
yes, I have
connect with
very
you? Yeah.
simplified. is it? Where is it? Where is it?
Okay. So guys, please don't forget to fill up the feedback form. We need it for the speaker, for us, so that we know how to grow better. And so thank you, Ayush, for that patient answering of all the queries, and thank you guys for being there on a
Yes.
Saturday morning to hear to his session. So thank you so much, Ayush. It was
Thank
such
you
a
so much,
nice,
ma'am, for
enlightening
organizing.
session.
Yeah.
Enlightening, really. I
Please
mean, I'm
feel free. Thank you, everyone, for
yeah, I'm
joining.
not much. I don't know much about electronics industry, but today I got to
Thank
know quite a
you.
bit.
Yes, I
Thank
hope
you.
I explained it in very layman terms,
Yes, yes, for sure,
but
for
in
sure.
case you have any further queries, I'll be happy to assist. Okay.
Yes, thank you. Thank you,
Okay.
guys. Please be there next week. We are having a session with a UK person who's going to talk about study, job opportunities, life in UK. So yes, so be there next week. Thank you, guys.
Thank
Have
you.
a
Bye
beautiful
bye.
weekend. Thank you.
Bye
Bye.
bye.
Thank you, Ayush. Thank